All right, so we're going to use zeros to graph a polynomial function. First off, what are the zeros of negative 3x times x minus 4 times x plus 3? We know this. What are they? Can't hear you. That's two of them. So if you're not sure what's going on here, we're doing the ZPP, zero product property. X minus 4 is 0, x is 4. That one's x equals negative 3. And the one that kids like to forget is that first one. That's the one kids like to forget. Negative 3x is 0. What does x have to be? 0. All right, so if I go off the side, I do a quick graph. Since those are my zeros, they're also my what? X-intercepts, that's right. I should have been writing word pairs, sorry. But I cross the x-axis at 0, 0. I cross the x-axis at 4. And I cross the x-axis at negative 3. Now you'll notice the next thing I ask is, if this thing was in standard form, what would the power function be? I'm not asking you to FOIL and then double distribute. I'm saying do a little bit of near math. What would the first term be? A little louder. A little louder. A whole lot louder. Gosh, it's quiet. Aren't you a cheerleader? So, Lydia said, negative 3x times x is negative 3x what? Do it again. Negative 3x cubed. You don't have to do everything to get the first term. The power function is negative 3x cubed. How does that help me? Because I memorize indicator. Negative x to the odd. How does she start her day? Odd. How does she end her day? Low. Now, we haven't talked about multiplicity yet, but every one of these factors have an understood one. We'll talk about that in just a minute. What that means is you cross the x-axis. That's an odd multiplicity. But this thing has to come in from up high. It's going to pass through that x-intercept. Some point in time, it's going to turn back around. It's going to go back up, and what's it going to have to do? What's it have to do to defend low? It's going to have to go back down. Now, this isn't a perfect graph. It's not meant to be a perfect graph. But it's a pretty good graph. It tells me things. I can answer questions from this. I can answer inequalities. I can answer things like, where is it greater than 0 or less than 0? It's a good enough graph by and large. All right. Any issues, anything we've done? All right, let's just do one of these. Just factor each function, then use the real zeros to sketch its graph. That's an x to the 4th. What do you already know about it? Starts high and ends high. Okay, good. Factor it. Take a minute. Factor it. A special pattern. You don't have to know, but it's a special pattern. Again, I'm doing the g of x equals. One of these days, I can become a friend. It's going to take to make an x to the 4th kids. X to what power, x to what power? Second. In fact, that was Now, as you can factor x squared minus 9 again. A lot of y'all wrote x squared minus 9 times x squared plus 9. You are not done. You are not done with factoring. I'm very happy you wrote x squared minus 9 times x squared plus 9. Because that's half of it. But you're not done. When you take a test, I can't sit over your shoulder and be like, you're not done. You can't do that. Could. I'm not going to. How's x squared minus 9 factoring? How's x squared minus 9 factoring? I know you know, you're just being quiet. Elizabeth, how's x squared minus 9 factoring? There you go, speak up. Since there's nothing in the middle, we want your 3's to be opposite signs. Because they have to add to the nothing in the middle. All right, so what are your zeros? What are your x-intercepts, your zeros? You got 3 and negative 3. As an order pair, you have 3, 0, and negative 3, 0. These guys, what are they going to do? Think about doing here's 2 steps here. X squared is negative 9. X is going to be the square root of negative 9. Real or imaginary? Because they're not real, they're imaginary. So I don't need to worry too much about them. Now, anybody know where the y-intercept is? I don't usually do this, but where's the y-intercept? What's that? Negative 81. Just to find the y-intercept, what do you let x be? 0. So this thing's going to cross way on down here at negative 81. It's got intercepts at plus and minus 3. And x to the 4th will start her day high and end her day high. And unless there's some stuff in the middle, like plus some x squared or plus some x's, it's going to look just like x squared, except it's going to be a little flatter on the bottom. That's what it looks like. With all m behavior too. Started high, ended high. All right. The next thing in your notes is multiplicity of zeros. There's actually a pretty good little slide you look at in here, so I kept it. So how does a multiple zero affect the graph of polynomial? The only thing difficult about it is they're using letters A, B, and C. Now, so here we have this factor x minus a squared. That means the 0 is at A, right? So I find A, and the 2 there. And it says the multiplicity is 2, we have what's called a turning point. Here we have B, we've got an exponent of 3. It's a crossing. Cross the x-axis. This x minus c, what's its understood exponent? Anybody know what the understood exponent of x minus c is? 1. Happens one time. As understood exponent of 1. Multiplicity is 1, crosses the x-axis. So there's some concepts here about multiplicity. Even multiplicity, which is the number of times a 0 happens, touches the x-axis. Touches. The 0 happens an even number of times. The 0 happens 2, 4, 6, etc. times. So it's always going to be an even multiple. That'll come into play on 3-7, I think, 2 sections from now. These odd multiplicities, these 1s and these 3s, what they do on the x-axis? I didn't think you were paying attention to them. Oh, you're right. Here's an odd multiplicity. What's it doing? Crossing. Here's an odd multiplicity. What's it doing? Crossing. Odd multiplicity. Crosses the x-axis. And since it's odd, that means the zeros happen an odd number of times. 0 happens 1, 3, 5, times. It's even an odd multiplicity. By and large, in Algebra 2, you can get by with a pretty simple concept. If you see x minus something squared, you have the number 2, and a 2 starts with a t, doesn't it? Well, t means you touch. By and large, you can get rid of it, you really can, because they don't try to make things too hard. Doesn't mean you don't need to realize that it's even, but 2 means touch. All right, so what's up next? Describe the behavior of the graph of the function at each of its zeros. All right, so let's look at f of x. What are her 3 zeros? Zeros, 1, 0. We have x equals 0. You guys are telling me x equals -4. What's the other one? X equals 1. There's a reason I'm writing it like this, by the way. It talks about describing the multiplicity. I have no desire to write the multiplicity. I'm going to use the letter M. Okay? That's supposed to be a 0, isn't it? Like a 6. Talk about the multiplicity of each of these zeros. The easiest one's probably this guy. What's her exponent? 4. That's the multiplicity. That thing happens 4 times, because if you were going to write it, wouldn't you write it 4 times? So this guy happens 4. All right, x equals -4. By that factor, x plus 4. What's the understood exponent? A 1. So what's the multiplicity? 1. And this guy right here, just x. What's its understood exponent? So what's the multiplicity? 1. Now, I'm supposed to talk about behavior. Behavior is derived from multiplicity. The numbers 1 and 1, what are they? Odd. What does odd multiplicity do when it comes to the x-axis? Cross it. Let's do cross the x-axis. About 4. That's even. Touch the x-axis. I should probably write the word odd here. I should probably write the word even. When you go back and look at your notes, you might not realize that you're dealing with odd and even. So I want you guys to do the next one. Y'all are telling me that thing has 3 zeros. Check again. That should have 0. It's right. Left. You're actually across the x-axis. The zeros you find here, they are about the graph. The imaginary things affect the x-axis. You want this to graph, it's not understood. Put 9. Now, with finding these zeros, you guys aren't doing anything wrong by finding them. You're really not. But you get plus or minus 3i. This is about the behavior of the graph. It does have a multiplicity. Each of those zeros happens one time. They do. Didn't do anything wrong. Let Mackenzie wrote multiplicity is 1. She's right. They each happen once. But does it affect the graph? So I don't want to talk about anything about it. Doesn't make any sense. I'm glad you found them. I am. I'm just saying they're not going to be what we're looking at because they're not about crossing the x-axis. You got x equals 1 from this factor. How many times it happened? 5. What's that mean? Cross the x-axis. What's the last zero? X equals what? -2. What's the multiplicity? What's that mean you do on the x-axis? Gotcha. All right, good timing. Tomorrow you have that transformation quiz. There's a few extra practice sheets on the table if you want it. It's up to you. That practice sheet's due tomorrow, by the way.